Now let's see section 2 of part 2 of chapter 2. From chapter 2 we are going to see the section 2, that's all lesson 2. That's about acceleration of an object. So what is the meaning of acceleration? So acceleration is defined as this is the rate at which the rate of change of velocity. Or when, like as you can see here in this train, the train is said to move like acceleration or deceleration if and only if the velocity changes. So when there is change in velocity, we call that the object is accelerating. It can be like positive change or it can be negative change. Whatever the change is, an object is said to have an acceleration if the velocity changes. So acceleration is defined as the rate of change of velocity, that is change of the change in velocity divided by change in time or time interval. So time taken. So when an object is like changing its velocity, either it can be falling down or moving horizontally, if the velocity changes, we call that it is in an acceleration, in a kind of motion said to be accelerating, or a body said to be accelerating if and only if the velocity changes. Here the velocity must change, otherwise if the velocity remains constant, the object is in a uniform motion. But if the object changes its velocity, we call that it is accelerating. So, and the acceleration is defined as the change in velocity, there must be change in velocity, divided by time interval or change in time. And this is called delta, and this is delta is called change. This is a Greek word called change. So when we have change in velocity, we will have change in time. Like for example, this is the final velocity minus initial velocity divided by time. So when there is change in velocity, we call that the object is accelerating. So when you say change in velocity, it may increase its speed or it may decrease the speed or the velocity. So when you say acceleration, we mean that the change in velocity. So when you say change in velocity, that is the difference between final and initial velocity divided by time. So as you can see here, now let me just see this one. In this particular case, the train is now changing its velocity. So or when you have, like for example, when the train starts motion, it was initially at rest, or the initial speed of the train was 0. It was initially at rest, but it was 0. But when just after some time, it will increase the speed. The speed will increase. This is when the train starts movement. Like when the train was going, and if the train wants to stop, it was initially moving at greater speed. It has a speed different from 0. And when it stops, its final velocity becomes 0. In this case, we call that the train is decelerating, or the train is said to be, it's said to have a negative acceleration, or the train is said to be slowing down. But when the case when the train starts from rest, it is said to be accelerating, because it was initially at 0, or it has a 0 initial speed. Now the speed is increasing. So in this case, we call that the train is accelerating. Here it is said to be accelerating or speeding up. So when the velocity of a body is changing, the body is said to be accelerating. So to have an acceleration, the velocity of the object has to be changed. Or if the velocity of the object changes, we call that the object is accelerating. That's what you have to know. So acceleration is defined as the difference between final velocity and initial velocity divided by time. So here the acceleration is the difference between final velocity and initial velocity divided by time. So the SI unit of acceleration is derived from the unit of velocity, that is meter per second. The SI unit of velocity is meter per, that's change in velocity, divided by change in time. So the SI unit of change in velocity is meter per second, divided by the SI unit of time is second. Meter per second per second. Now this is the same as meter per second divided by second over 1, which is equal to meter per second multiplied by 1 over second, which is equal to meter per second square. Meter times 1 is meter over second square. So the SI unit of acceleration is meter per second square. But we can also measure acceleration as centimeter per second square, or millimeter per second square, or dime per second, kilometer per hour square. You can do different things, but this is the SI unit of, this is the SI unit of acceleration. So the SI unit of acceleration is meter per second square. So here what we have to do is, we have three possible cases for acceleration. Cases, the possible values of acceleration. The possible values of, so we may have the acceleration of the object can be positive, or the acceleration of the object can be negative, or the acceleration of the object can be 0. So we will have a negative positive acceleration if the particle is speeding up, or if the final velocity of the object is greater than its initial velocity. So this is a case where we have, this is a case where we can have a positive acceleration. So if the final velocity of the object is greater than its initial velocity, then the value of acceleration will be positive, because v is greater than u, so the difference between big number and smaller number will be positive. So we will have a positive acceleration if the object is speeding up. This is very important. If it is what? Speeding up. If the speed of the object is increasing per given time. This case, this is a case where, like for example, if the car is going slowly and starts to speed up, starts to accelerate, in that case we will have a positive acceleration. Well, the second value of acceleration is negative. We can also have a negative acceleration if or when the value of the final velocity is less than the initial velocity. This means the car is now slowing down or retarding. In this case, the car is slowing down, or this is called retardation. Speeding down is called retardation, or we can also call it deceleration. So when the car slows down or decreases its velocity, then the car is said to be said to have a negative acceleration. So in this case, the value of acceleration is negative, means the car is, or the moving object is slowing down, or it's going to stop, or it is retarding. The third case is, this is the first case where we have a positive acceleration. This is the second case where we can have a negative acceleration, and this is the third case where the acceleration of the object is 0. In this case, the value of acceleration is 0 if and only if the final velocity of the object is equal to its initial velocity, or if the particle is moving in a uniform motion, or we call that the particle is in a uniform motion. And this kind of motion is called uniform motion. That is a motion with constant speed. So here what you have to do is, the value of acceleration can be 0 provided that 1, either the object is at rest, it is not moving, or the particle is in motion, but motion with constant speed. So there is no change, because to have an acceleration there must be change in velocity. But in this case, the velocity is not changing. The velocity remains constant. So in this case, the value of acceleration will be 0. So acceleration is 0 doesn't mean that the object is at rest. The object can be in motion, but motion with constant speed, or motion with the same speed throughout the motion. So these are the three possible values of acceleration: positive acceleration, negative acceleration, and zero acceleration. Now let's solve some examples. A train initially moving at a speed of 12 meters per second. That's the initial speed. Let's write down the given quantities. Initial speed of the train is v, that's u, for this case is 12 meters per second. Speed is up to, that's v final, is 36 meters per second, and the car is speeding at, changing speed in 120 seconds. So we are asked to find what is the value of the acceleration. We want to find the value of acceleration. So to find the acceleration, we use the formula. We know that acceleration is defined as the difference between final minus initial speed divided by time. Acceleration is defined as the rate at which the velocity changes. So this is equal to the final velocity is 36 meters per second minus 12 meters per second divided by 120 seconds. This is equal to 36 minus 12 is 24. This is 24 meters per second divided by 120 seconds. So you can use calculator in order to find the quotient of these two numbers. That is 24 divided by 120 will give us, this is equal to 0.2 meter per second square. This means the train is changing its speed by 0.2 meter per second in every second. That's the mean. The train is changing its velocity by 0.2 meter per second every second. For every rise in 1 second, the speed of the train increased by 0.22 meter per second. That's the physical meaning of this acceleration. Now let's move on to the second example. A car traveling at 7 meters per second, that's the initial speed, accelerates uniformly at, this is a value of acceleration, 2.5 meters per second square, to reach a speed of 12 meters per second. So how long does it take for this acceleration to occur? We want to find, when you say how long, we are asked to find t. So let's list down the given quantities. A car which was initially traveling at a speed of 7 meters per second, that's the initial speed, and the final speed is 12 meters per second, and it was traveling at the rate of 2.5 meters per second square. So we want to find, what we are asking is, we want to find the value of t, the magnitude of t. How long? T. So let's find t. Solution. Well, let's use the definition of acceleration. Acceleration is defined as the rate of change of velocity, that is final velocity minus initial velocity divided by t. Now let's make t the subject of the formula. Then cross multiplying, then a multiplied by t is equal to v minus u. So divide both sides by a in order to find t, so that this s will cancel each other, then t is equal to v minus u divided by a. Now let's substitute the given quantities. V is 12 meters per second, minus initial speed is 7 meters per second, divided by the acceleration 2.5 meters per second square. So 12 minus 7 is 5 meters per second, divided by 2.5 meters per second square. This is equal to, you can use calculator in order to find the quotient of these two numbers. 5 divided by 2.5 will give us 2. This is 2 seconds. because meter per second divided by meter per second square is equal to meter per second multiplied by second square over meter. Now let's simplify, cancel this meter by meter and this square by this. Finally we'll have second, which is the sign of time. So the car will have a speed of 12 meters per second after 2 seconds. Let's move on to the third example. Suppose a treadmill has an average acceleration of this much. How much does its speed change after 5 minutes? We want to find the change in the speed of. So let's list down the given quantities. The value of acceleration is 4.7 multiplied by 10 to the power of negative 3 meter per second square. And t is given. T is the change in time. That's change in time. We can call it t, or change in time is 5 minutes. And we know that the unit of time is second. So we have to change the minutes into seconds. So 5 times 60 will be 300 seconds. So we want to find A. In this case, we are asked to find A. How much does the speed change in velocity? That's what we want. B. If the trivial initial speed is much, what is the final speed? We want to find V. So now let's solve it. Solution. We know that acceleration is defined as the rate of change of velocity. Change in velocity over change in time. I'm solving A, part A. So we want to find change in velocity. Does its speed change? We want to find change. So cross multiplying, making change in velocity. So the change in velocity is now given by A multiplied by change in time. So this is the same as the value of A is just here it's 4.7 times 10 to the power of negative 3 multiplied by meter per second square. I can use meter per second square here. Here meter per second square multiplied by T. T is 300 seconds. That will be 3 multiplied by 10 to the power of 2 seconds. Now I want to simplify this square by this. Then we will have 4.7 times 3. Let's multiply 4.7 times 3. 4.7 multiplied by 3. It will be, it's now 14.1. This is 14.1. 10 to the power of 3 I can add. When I multiply 10 to the power of negative 3 multiply by 10 to the power of 2, this will be 10 to the power of negative 1. You add the exponents. Multiply by 10 to the power of negative 1 meter per second. That's the change in velocity. So this is the same as, you can write, you can stop here or you can write here, it is the same as 1.41 meter per second. Because we divide 10 to the power of negative 1 is 1 over 10. So 14.1 divided by 10 will be 1.41 meter per second. That's A. This is the change in velocity. Now for case B, we want to find the final velocity. So we know that change in velocity is defined as the final velocity minus initial velocity. So here initial speed is given. That's U is given, that's 1.7 meter per second. And I know the change in velocity. Change in velocity is here. I can use this right here. That's 1.41 meter per second is equal to final velocity minus initial velocity 1.7 meter per second. Now collect number to number. So here it will be 1.41 meter per second plus 1.7 meter per second is equal to V. Now the final velocity is equal to, I take this to the right. I'm collecting this to the left. I'm taking from the right side to the left side. I'm collecting numbers to number. So when this is negative, when I take to the left, it will be positive. So final velocity is, we add this to 1.41 divided by plus 1.7. It will be 2 points. Then we'll get, it will be 3.11. The final velocity is 3.11 meter per second. This is the final velocity of the treadmill. So here the change in velocity is 1.41 and the final velocity is 3.11. Let's move on. Example number 4. What will be the acceleration of a turtle that's moving at a constant velocity of so here given we know that u is initial speed is 0.25 meter per second, and the final velocity is also 0.25 meter per second because it's traveling at a constant velocity. So we are asked to find the acceleration. What is the value of the acceleration? Solution. We know that acceleration is defined as the change in velocity, that's v minus u divided by t, which is equal to 0.5 meter per second minus 0.5 meter per second divided by t, whatever the time t. So 0.5 minus 0.5 0, and 0 divided by t is 0. So the value of acceleration is 0. This means the turtle is traveling at a constant velocity. If the velocity of the object is constant, the value of acceleration will be 0. Because to have an acceleration, there must be change in velocity. But in this case, we don't have change in velocity, so the value of acceleration will be 0. So this is the motion is, in this case, the motion is said to be uniform motion. In this case, the motion is a uniform motion. Means motion with constant speed. The speed is not changing. It doesn't change. That's why the value of acceleration is 0. That's all what we have.